Hey everybody, this is Mr. Ainsworth here, and we're going to get into a cool lesson on how to solve systems by graphing. Two ways. We're going to do it manually on paper, and then we're going to use the graphing calculator, the TI-84 here, to verify the solution. So we're going to use what's called the TI-84 graphing calculator to verify the solution. In fact, we're going to verify it manually first, and then we're going to go to the calculator, and I'll show you the steps on it. It's pretty simple of how to check your answer on a calculator, which is probably more precise than you are on paper. Okay, because solving a system by graphing doesn't always give you the exact answers you're going to find out, and so you need a tool like the graphing calculator to help you on the more difficult cases. So let's get started here. The first equation in our system here of two equations is y equals negative 3x minus 4, and that, my friends, is in slope-intercept form. All right, y equals mx plus b. So I can see that the slope is negative 3, or negative 3 over 1, which means down 3, right 1. I can also see that this y-intercept here is negative 4, or 0, comma, negative 4. That's called the y-intercept. Okay, so what we're going to do is we're going to plot that y-intercept first at negative 4. This is the y-axis, x-axis here. And then from there, we're going to go down 3, right 1. And notice that we're almost off the grid. So what we do is reverse that. We go up 3, left 1. Up 3, left 1, and repeat the slope. Up 3, left 1, way up here. Okay, and let's be precise. So get out your straight edge. Don't freehand these things. Okay, and go ahead and plot your line. Okay, there's your first function. That's y1. Okay, that's y equals negative 3x minus 4. Now the other one's in standard form, so you could do this by graphing or finding the intercepts using the intercept method, or you can isolate y. For the purpose of this video, I'm going to isolate y. Okay, so here we go. Let's add the opposite of your x term here, your mx term. And I get 3y is equal to 7x minus 12. I'm going to divide through by 3 on every term. And I get y is equal to 7/3 x. There's your slope. All right, minus 4, because 12 divided by 3 is 4, and there's your y-intercept. So notice that they have the same y-intercept. So I already have an intersection point. So this is pretty straightforward. So start here, and I go up 7, right 3. So up 7, that's 4 and 3 is 7, right 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 to the right. Plot a point. So I use my slope. Up 7, right 3. There we go. Plot your line. Get your straight edge out and draw that line right through the 2 points there, and then state your solution right here. So that right there is the y-intercept, 0, comma, negative 4. Okay. Now for it to be a solution and to verify that you have the correct solution, what you do is you substitute it into both equations and so show that it's a solution to both. Okay, you have to test it in both solutions. So we're going to substitute it into the first one and test it, and then we're going to test it in here. Remember, when you test it, you know that x is 0 and y is negative 4. So here we go. We're going to test both. Okay, so if this is correct, it has to satisfy not one but both of them. All right, so we're going to start off with negative 4 because that's a y value. So negative 4 is equal to negative 3 times the x. X is 0 minus 4. Is this true? All right, so we know anything times 0 is 0 here, so that gets wiped out. And so we have negative 4 equals negative 4, and that's obviously true. Okay, so that tells me that it satisfied the first one, doesn't satisfy the second one. So is negative 7 times 0 plus 3, all right, times y, which is negative 4, is that equal to negative 12? I don't know. Let's find out. So we got 0 here. This is negative 12, and negative 12, of course, is equal to negative 12, and that's true too. So it satisfied both. So I know that this right here, 0, comma, negative 4, is a solution to the system. Why? Because it satisfied both equations. Okay, I substituted them in, and I knew that they satisfied both because I ended up with true statements here versus something false, and therefore I know it's a solution to the system. The other way you can do it is by using the TI-84. So here we go. Let's turn this baby on and learn how to input the functions, which both must be in slope-intercept form. All functions, it turns out, on this calculator anyways, have to be entered in what's called explicit form, where it's y equals something. Every equation on the TI-84 has to be in the form of y equals, I was thinking of the calculator now. Y equals, something, okay? That's called explicit form. So here we go. Hit the y equals button. That's what's called your equation editor. They call it that because that's where you edit your equations or functions in the system. Now the first one is negative 3x minus 4. Now the negative button is down here at the bottom. Okay, don't use the minus sign, you're getting an error. So go negative 3, all right. X, your variable button is in the top left. Hit the X button. All right, minus, use the minus sign. The minus operation is on the right. All your 4 operations are on the right. The negative sign is down at the bottom. Big difference between a minus sign, minus operation, and a negative sign. Okay, and then you type in 4, and there's the first one. Go down to y2 and enter the second one. Now the second one is down here. Okay, my first one was up here. Okay, so my second one, let me go back to my calculator now, is 7/3 x, so I go 7 divided by 3, and then hit the variable button, x, and then I subtract 4. Okay, now a little trick here, instead of hitting graph immediately, I'm going to usually go to zoom and set it to Z standard, number 6. Write that down in your notes, zoom 6. Okay, and that centers the graph a little bit for you, because sometimes if you just hit the graphing button, you may not see everything that you need to see. And notice that they're color-coded on the new graphing calculators. So the first function's in blue and the second function's in red. Okay, so this is y1 and this is y2. And notice where they intersect right here on the y-axis. But we need to get a little, let's zoom in here a little bit. Let's zoom in. That's number 2. And you have to hit the enter button afterwards. Now, notice that I do that, I can't see down low enough. My x minimum, or excuse me, my y minimum is too small. So I'm going to hit window and adjust the window settings. So y minimum is at negative 2.5. I know I needed to set it around negative 5 here. Ooh. Yeah, negative 5. So let's go down here to y minimum. Make sure you get the right one. Let's clear that. Let's set it at negative 5. Make sure you hit the negative button at the bottom and then hit graph and watch what happens. So I just adjusted how I view the calculator. It's called the window. Anytime you can't see either at the top, the right, left, or whatever you need, you can adjust the window and it will allow you to show what you need to see. So you can see down here it's 1, 2, 3, 4 units below. It looks like they're intersecting here at 0, negative 4, but let's get a better look at it. So I want you to hit trace, and we're tracing the first function. If you hit the up arrow, you can switch to y2, the second function. If you hit it again, you get back to the first function. You can trace along either of the lines, and what trace means is that you can move it along the line. Okay, so it looks like it's at 0, negative 4. And look at the calculator at the bottom here. 0, negative 4 on the first function. If you enter 0 and then you hit enter, the y coordinate is negative 4. So it looks like that's it, right? Okay, but tracing doesn't always give you the exact value. You have to actually calculate it. And if you notice that the calculate is in blue. So to calculate on the TI-84, you go second, trace, which takes you to your calculate menu. And if you want to intersect, you hit number 5. Okay, if you look at your steps that I gave you in class on the handout, the TI-84 graphing calculator steps, it states that. Okay, you hit second trace, which is your calc, hit number 5 for intersect, and then it says hit enter 3 times. It asks you 3 questions. What's your first curve? Well, it's y1, so you hit enter. says, what's the second curve? Well, that's y2, and you hit enter. Because it needs to know what functions you want to intersect. And this calculator is able to intersect at least, I think at most, nine functions all at once. So you got to tell it what you want to intersect. So y1 and y2, and this says, put me at your guess. And since the cursor is right there, okay, I'm not going to move the cursor. I'm just going to hit enter. So basically, you hit enter 3 times after you go to intersect mode, and notice the coordinates 0, -4. All right, and that tells you you're correct. So you verified it on paper, you verified it on the calculator, and you're good to go. The only thing you need to do is get good practice on that, which means you need to do a lot of examples. So that's the first case where we have a single solution. That's case 1. Okay, and notice here in the lesson here how I titled it. Come on. I don't know why it's delaying here. My computer's thinking here. But it's what we want to do is explore the 3 different cases that we may have when you solve systems. I'm going to pause this to figure out what's going on here with my computer. Okay, so we explored the first case where the solution has a single, or excuse me, the system has a single solution here. You know, it's when 2 lines intersect, they have a solution. It's the intersection point. So keep that in mind. The solution is the same thing as the intersection point. All right, that's not the case for all systems. So let's explore the second case. All right, so let's go to example number 2. And let's do it by hand, and then we'll verify with the calculator. So you got y plus x here equals 1. We need to get it in, we need to isolate the y variable and get it into slope-intercept form. So let's do that. So you have y equals -x plus 1. The slope is -1. The y-intercept is 1. So let's graph that one first. So you start up here at 1. And this is down one, right one. So down one, right one. It has negative slope, so it goes to the lower right, not the upper right. And then reverse it so you can see the line form. So use a straight edge here. All right, and graph that line, be accurate. And then start working on the next one. So let's add the opposite of the x term here. Ooh, don't do that. I got to look ahead here. That was a bad move. The y is right here, and it's only being multiplied by 2. So this one's simple. You just divide everything by 2. So what do you get? You get -x minus 2 is equal to y. Okay, that's how simple that one was. If you want to rewrite it, it looks like this. So right here, the slope is -1. And right here, the y-intercept is -2, or 0, -2. So let's plot at -2. Okay, start plotting -2 on the y-intercept. And use a slope of -1. So, oh, these are parallel because they have the same slope. So let's plot the line using the same slope. And notice they're parallel. Parallel. Why? Because they have the same slope. Means they're parallel. Okay, so let's graph that line too. Now let me see. The solution to the system is the intersection. The solution to any system is the intersection. Okay, and this system has no intersection. So that tells me here, no intersection, no solution. So no intersection, no solution. It's as simple as that. Why? Because they're parallel and offset. Okay, now we can verify that with the calculator real quick, so let's go through the steps. Okay, let's go hit the equation editor here. Press clear on both of them. Okay, go back up to y1 and let's re-enter. Okay, the first equation, or function, excuse me, not equation, function, is -x minus 1. So enter in -x plus 1. Go down to y2 and enter in -x minus 2. And then hit zoom 6. And watch what happens. Okay, there's the first one, and there's the second one. Now, it doesn't look like they have the same slope. It looks like they're parallel, but it looks like the slope on my paper here is a little bit different than there. And the reason why is because the graph or the scale is not the same. We want to square it out. So we're going to hit zoom square, number 5 this time. Watch this. This sets the scale the same on both axes, and now look at this. Now they have the same slope as what we have on the graph. So I use zoom 5 here for square. So zoom 5, and that represents square. That means it sets the scale on the x-axis the same as the y-axis, so it looks identical to what we have here in our notes. Okay, so zoom 5 to square it out. That's case 2, no solution. Case 3, what does that look like? Well, let's find out. So let's take our first function, y plus 3x is equal to 2, and let's get this in slope-intercept form by adding the opposite first, as we always do. And you get y equals negative 3x plus 2. We have a slope in the y-intercept, so let's graph from there. So from there you get start at 2, and the slope of negative 3 is down 3, right 1. So go down 3, 1, 2, 3, right 1, 1, 2, 3, right 1, and then reverse it. So up 3, left 1. Okay, and then be accurate, be precise. All right, draw the line right through those points using a straight edge. Okay, now let's do the same thing over here. Let's subtract 6x, that is, and you get 2y is equal to negative 6x plus 4. Divide everything by 2, and you get y is equal to negative 3x plus 2. Oh my God, look at this. Okay, they're the same equation, or you can say function. Okay, they have the same slope and y-intercept. Same slope and y-intercept. Okay, because of that, they're the same line. Okay, so y1 here is the same as y2. They're the same line. So they overlap at an infinite number of points. So they overlap at an infinite, everybody say infinite, at an infinite number of points. Every line has an infinite number of points. And if they overlap at an infinite number of points, that means they intersect everywhere. Okay, and if they intersect everywhere, that tells me we have an infinite number of solutions. So we say that this system has an infinite number of solutions. Okay, so you just saw 3 different solutions here. You saw a system that has no intersection, no solution. It's parallel and offset. Okay, you saw a system that overlaps in an infinite number of points because they're the same equation and function, which means they have the same slope in the y-intercept, which means they have an infinite set of solutions here. Okay, an infinite number of intersection points. They intersect everywhere. Why? Because they're the same line. The first system was a single solution. That's case 1. You have a single solution in the form of an ordered pair. All solutions are in the form of an ordered pair. Okay, remember that. You're looking for x comma y here, where they meet, where they intersect. Okay, so keep that in mind at all times. Okay, so you may have a single solution, you may have no solution, you may have an infinite number of solutions. Okay, and now the only thing you need to do is get good at it. So in your homework here, which is attached, all right, 6-1B homework here, you're going to solve it manually. All right, do it manually, which means on paper. So do it manually, and I want you to verify using the TI-84. So with graphing calculator of your choice. I have a class set of TI-84s, so you may use those. TI-84 graphing calculator. I'm talking about this bad boy right here. Okay, so keep that in mind. All right, well, as always here, this is it's been fun. It's been real. It's been a lot of fun solving systems here using some technology here. You could use Desmos too. And if you don't know what that is, go online and check this program out. It's one of the coolest online graphing calculators on the planet. Desmos. It's an online graphing calculator system. Online graphing calculator, and it is awesome. Okay, I'm saying awesome. So check that out. You can do that at home, by the way. It's free too. It's free. There's no cost. Okay, so check Desmos out too. There's GeoGebra too. GeoGebra. There's this one too. Okay, I think that's free too. So there's two online graphing programs that are free, Desmos, and the other one is called GeoGebra. And guess what? They are both free. Check them out and do your best. Have fun with it, okay? Because it is fun learning new things. And I'll see you in my next lesson. Bye-bye.